Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am an associate professor, Department of Computer Science, Arbat College, University of Delhi. Moving on, we have entered into the concluding lectures of our topic multi-threading, and in the previous lecture we have seen the concept of synchronization not only theoretically but practically as well. And here in this lecture which all topics we are going to cover. One is about the states of thread, how they are maintained inside the programming, that we are going to see. Then I can say a burning question which always comes to the mind of the viewers or students is what is the difference between start and run, and then final some concluding remarks about this the concept of multi-threading. Let us begin with the thread state. Now please recall that we have gone through the life cycle of a thread in a very detailed manner, and I am taking the topic from there only. So, thread state, when we talk about a thread can exist in number of different states. Now, what those different states could be, that could be a new state, runnable state, blocked state, waiting state, and so on and so forth. So, there are multiple states in which a thread can exist. And in order to obtain the current state of a thread, we have a function which is named as get state, and this is the method which is defined by the thread class. And how this method is going to be executed is, the general form here is thread dot state get state blank parenthesis. Now what is this so this get state method is actually going to return one I can say enumerated constant or one enumeration which we called as thread dot state. So it basically returns a value of type thread dot state that indicates the state of the thread at the time at which the call was made. So that means whenever we are calling this get state method at that point of time, whatever is the state of the current thread, that state will be returned as the answer or as the return value of this method. And this thread dot state is actually an enumeration defined by thread class, and I am assuming here, I am sure that you all are aware of what is this enumerated data type. So what all could be the possibilities under this enumerated data type? Let us see that. So one possibility is the blocked, and as you all are aware that traditionally or typically we can say that enumerated constants are written or enumerate options under this enumeration data are written in capital letters. So here one state we have blocked in which thread has been suspended its execution because it is waiting to acquire a lock. Then there could be another state which is new. This is for a thread which has not begun the execution, that means it has just been created, only start has worked upon it, not the run. Then we have runnable state which is for the thread that is either currently executing or will execute when it gains access to the CPU. So either it is currently executing or it is we can say ready to execute. So the moment it is going to gain access to the CPU, it is going to receive access to the CPU, it will start running. Then we have another constant or another state which is named as terminated. This is for the thread that has completed execution. Then we have one which is timed waiting. This is for a thread that has suspended execution for a specified period of time. So for example, the best example here could be sleep. So in case of sleep, let us say we are giving 1000. So for so that 1000 represents milliseconds. So for 1000 milliseconds or for 1 second, that thread has been kind of suspended its execution. And apart from that, not only sleep but a timed waiting state can also be entered when a timeout version of wait or join method is being called. Another state is the waiting. This is for a thread that has suspended execution because it is waiting for some action, kind of some input output to occur, or it could the example here could be the thread is waiting because of a call to a non timeout version of the wait or join. If it is a timeout version of the wait or join, then the state of the thread will be timed waiting. If it is a non-timeout version of wait or join, the thread state will be waiting. Now, how are we going to kind of use this state? So, given a thread instance, we can use get state to obtain the state of a thread that we have seen. So, for example, I have written here 2 lines of a kind of piece of code which are going to determine that if the thread which is being called as thrd thread is in the runnable state at the time of the get state is being called. So, that means we are calling this get state on thrd and we are storing the answer, or we are storing the response inside the variable ts, and this variable is of type thread dot state, and what all could be the possibility of these values of thread dot state that we have just seen, that is new, timed waiting or only waiting or blocked or terminated and so on and so forth. So, thread dot state ts is equals to thrd dot get state if ts is equals to thread dot state dot runnable. So, here it is kind of the use of that constant which we have just seen. So, we have seen new, then blocked, then runnable, then waiting, then time waiting, and if we want to use for some higher purposes of programming, if we want to use those states, these can be used as we have given example in this if statement, that is if ts equals to thread dot state dot runnable. Then with this states, that how are these states are going to be utilized inside the program. Let me switch over the difference between thread dot start and thread dot run in Java. So, we have used 2 methods particularly from this class thread. These are actually the method start and run. So, the question here arises that what is the difference between start and run. So, when a program calls the start method, a new thread is actually created, and after this start method, the run method is executed on that thread which is created, on that very created thread we can say. But if we directly call the run method without the start, then no new thread is being created. Now, if no new thread is being created, then how, or we can say on what on which thread this run method will kind of execute. This run method can execute on the main thread which is created automatically. So, if we are directly calling the run method, then no new thread will be created, that means without start I am talking about, and run method will be executed as a normal method call on the current calling thread itself. So, we do not have any kind of new thread created because we have not used start, but yes, we do have main. So, main is the thread which is automatically created, for which we at least as programmers need not to go into calling start for the main at least. So, without that, if we are going to do, so the run method will be executed as a normal method call on the current calling thread itself. And please remember that here, as we have not used start, no new thread is being created, hence no multi-threading is going to take place. So let us try to see this with the help of a very simple example. So here we have a class myThread which extends the thread, although we can use implement runnable here also, but here as we are actually not kind of using another classes inheritance of other classes or extension of other classes, we are using it we are using the extension of thread class here. So we have public void run, then we have within this we have system.out.println which says current thread name, plus here we have used one kind of we can say variable which is thread.current_thread.getName. So this basically is going to give us the name of the current thread on which this run method is being executed, or this run method is being kind of we can say implemented, and this belongs to the class thread. So after this line, as you can see on the screen, that we have printed this get name, and then we have printed a small statement which says run method called. Now please notice that here we have not used any start method. That essentially means no new thread is being created. And now inside the class thread demo, in which we are going to write main, my thread t is equals to new my thread and t dot start. Here we have used a t dot start method, and here we have used just a run method. So what is actually happening inside this my thread which is extending the class thread, there is a run method which is kind of printing the current the name of the current thread on which the run is going to be executed, and within the we can say within the main function or within the main method, we have created one reference variable of that class myThread by the line myThread t is equals to new myThread, and we have called t dot start here. So the two things, one is t dot start and another one is that a run method which we have just seen. And now what will be the output? So the output says current thread name thread 0 and then run method call. So from where this output is coming? So basically what is happening here is inside this main method, when we have created one instance of the class myThread, and we have started we have actually created one thread t dot start, but with this t dot start we have not given kind of or through any other method in the program we have not given any of the we can say name here. So the start method of the thread class instance, a new thread is being created with a default name. That is why the name thread 0, because we as programmers have not supplied any any name by ourselves, and then the run method is being called, and everything which is written inside the run method is executed on this newly created thread which is being kind of created with the help of our t dot start. Now this was actually a program in which we have seen these two methods working together or working with hand in hand, working together we can say, which is the run method and the start method. Now when we were when we have started the discussion between these two methods from the point of view of the differences between these two, I have told you that we can use run method even without start. So let us see that example. So that means what is going to happen to that program in which we have not used any of the start, we have just used the run method. So for that let us see the program which is available on screen. So class myThread extend thread public void run, then the name of the current thread system.out.println run method call. So, this is actually the class which is similar to the class which we have seen previously, and the similar exactly the same run method. What is the difference between the previous one and this one? That comes here when we talk about the class thread demo. So, class thread demo, when we see inside that we have one a main function, and in this main function we have created an instance of the class my thread. But instead of using that instance variable in order to execute the start, we have directly kind of executed run method as shown on the screen. So, my thread t is equals to new my thread t dot run. Now, what is the difference between this program and the previous one? Here, instead of t dot start which was there in the previous program, we have directly used t dot run. That means, this is the version of the program which is not having any of the start. So, what is going to be the output? So, the output will say current thread name main and then run method call. So, what has happened in the previous program, when we have started or when we have called this start method, a new thread has been created, and the run method was actually we can say called upon that particular thread which was just created. Here we have not created any of the thread because of the absence of start method. So, now this run method is going to be kind of called upon the current thread, and here the current thread is the main thread because no child thread has been created here. So, when the run method of the my thread is called here in this new version, no new thread is created and the run method is executed on the current thread, which is nothing but the main thread. Important point here is no multi-threading took place. The run method is being called as a very normal function call, we can say. So, we kind of understood the difference between the start method and the run method with the help of a program, but theoretically also we need to explore more between these two. So, I can say one cannot call the start method twice. If we say t dot start then t dot start again, so it is going to throw an illegal state exception. Why? Because you cannot create one particular single thread, you cannot generate the similar thread twice. So, one thread which is being created is in the kind of new state, and then on the similar thread you are calling that new state again, or you are kind of keeping that thread in the new state once more again. So, you cannot call the start method twice, otherwise it is going to throw an illegal state exception, and that is why the name is the exception has been named as illegal state exception. Whereas the run method can be called multiple times, twice, thrice, where as many as number of times as you want, as it is just a normal calling method. So, run method is something which is kind of starting the thread and executing whatever is being written inside the thread that can happen here. So, let us see this how this t dot start, if we are going to use this multiple times, how this is going to kind of throw the exception, or how this is going to behave. So, here we have that my thread which extends thread, then we have that run method which is printing thread dot current thread dot get name, and this we have seen in our previous program also, and run method called. So, that similar my thread class is being shown. Then inside the class thread demo, inside this function main, we have used my thread t is equals to new my thread. So, one more new instance variable of class my thread is being created, nothing new here. Then we have written t dot start and t dot start. So, whenever you are going to execute this particular program, which is going to have the multiple occurrences of thread dot t dot start and t dot start, here it is kind of going to give you the exception which is being shown here. So, please look into the output very carefully. So, the name of the current thread is being displayed as thread 0. That means that thread 0, that which is the thread having the default name thread 0, is being created. Run method call, this is the statement which is being kind of printed at the end of the method run. So, I can say one particular t dot start and then followed by run method has kind of executed properly. But then whenever this t dot start is being called again, then there is an exception in the thread main. And what is the exception? That is java.lang.illegal thread state exception at thread dot start, and which is available in this thread demo dot main file dot java. So, here we have this. So, that means you cannot use this t dot start as we have done here. This is going to kind of we can say throw the exception. Now, what will happen if we are going to use our instead of t dot start, if we are going to use our run method again. So, calling start method again raises java.lang.illegal thread state exception that we have seen, and we have also seen a complete program for that. Now, what will happen if we talk about this run method? So, here again that my thread the version of the my thread is being kind of created in the similar manner as it was done in the previous program. And the change which we need to do, which you need to do is within this main function, instead of writing t dot start and t dot start, write t dot run and t dot run twice. So, we are not using start twice, instead we are using the run method twice. So, now the situation which we need to observe is what is going to be the output of that particular t dot run and t dot run. As I have told you that this run method is going to be executed as a normal method call, there will be no problem to the system, or the system is actually I can say completely okay with being with this run method being called twice or even the multiple times. So, the one major difference between this start method and run method is this start method is there to we can say start method is there to create the thread, while this run method is kind of there to run the thread. So, that is what the basic difference between the two. And then the next difference which we have come up is t dot run can be used, or that run method is going to be used can be used twice or multiple times. So, if we use start and run simultaneously together. So, start creates a new thread, run method is executed on that newly created thread. If no new thread is created, calling the start function and the run method is executed on the calling thread itself. That difference we have also seen with the help of a program. Now, if we say start, that cannot be invoked more than one time, otherwise it is going to throw java.lang.illegal state exception. While for run method multiple invocation is possible. Another line of difference between the two is start is defined in java.lang.thread class, while run is a method of java.lang.runnable interface and must be overridden in the implementing class. So, here we have seen the differences between these two methods, start and run. Now, here as we are going to finish our topic of multi-threading, here are some closing remarks about this multi-threading thing. So, this concept of multi-threading is actually the key to utilize Java's multi-threading features. We have many built-in support for this particular task, and we can make it more effective by thinking in terms of concurrency rather than thinking them, or rather than thinking the task to be executed seriously. So, we can say the key to utilizing Java's multi-threading features effectively is to think concurrently rather than serially. So, for example, there are two subsystems within a program that can execute concurrently. We can have them as multiple threads. But one word of caution is here, that if there are too many threads, then they are going to degrade the performance of the program rather than enhancing it. Why? Because an overhead is associated with the context switching. So, if your CPU is switching the context from one thread to the next thread, kind of very frequently, as a result, because you have created many threads, your CPU is switching from one to next thread very frequently, then the CPU time will be spent more in changing the context rather than actual execution of the program. So, yes, there is a kind of limit, we can say, onto the degree of multi-threading also, which we should do, and this concept also goes with the programming, and that we have seen in our operating system series. Similarly, here this multi-threading, the degree of multi-threading should also be kind of explored in a controlled manner, we can say. Then only we will be able to reap the benefits of this multi-threading thing. So, this is all from my side for this particular lecture. Hope you have enjoyed this. Here is a list of references which is being used for the lecture. Thank you. I will see you in the next lecture. Till then, take care. Goodbye.